Assalamualaikum and good morning. My name is Yusli Hasbullah. Today, we will be presenting about a combined cycle power plant or CCPP and how fuel is converted into electrical power efficiently. First, what is a combined cycle power plant? A CCPP is a high efficiency energy system that combines two thermodynamic cycle. The gas turbine cycle, also known as the Brayton cycle, while the steam turbine cycle, also known as the Rankine cycle. The special thing about this system is that use the exhaust heat from the gas turbine to produce additional electricity using a steam turbine. This means we are generating electricity twice from the same fuel, which is why it is often described as getting two for the price of one. In 2026, combined cycle power plants are very important because they act as a bridge between traditional fossil fuel and a fully renewable energy future. Now let's move on to how the generation process actually works. Thank you.
Thank you, Yusli. Now I will explain the generation process, starting with the topping cycle, which is the gas turbine system. First, air into the air compressor, where it is compressed to the high pressure. Then this compressed air goes into the combustion chamber, where the natural gas is injected and burned. The high temperature, high pressure gas produced from the combustion expand and spin the gas turbine. This turbine is connected to the generator 1, which is produce electricity. But the process does not stop there. The exhaust gas leaving the gas turbine are still extremely hot. Instead of wasting this heat, it is sent to a system called the heat recovery system generator, or you call HRSG. The HRSG acts as a bridge between the gas turbine and the steam turbine. Now, my friend will explain more about the bottoming cycle. Thank you.
Thank you, Aima. In the bottoming cycle, the HRG uses the high exhaust gas to boil water and produce high pressure steam. The steam then drives the steam turbine, which is connected to generator 2. In some design, both turbines may even share the same shaft. After passing through the steam turbine, the steam goes into a condenser, where cooling water turns it back into liquid form. The water is then pumped back to HRSG, and then cycle repeats continuously. Now, let's look at the real example in Malaysia. The Sultan Ibrahim Power Plant in Pasir Gudang, Johor. Capacity is 1,444 megawatts. It uses GE9 HA.02 gas turbine. It has efficiency exceeding 60%, which is very high compared to other plants. Another example is the Edram Melaka Power Plant in Alor Gajah. Capacity is 2,242 megawatts. It is the largest CCGT power plant in Southeast Asia. Now, I'll continue with the advantage. Thank you.
Thank you, Ashraf. Now I will explain the main advantages of combined cycle power plant or CCPP. The first and most important advantages is high efficiency. CCPP can achieve efficiency level up to 64%. This means that 64% of the fuel energy is successfully converted into electrical energy. Compared to traditional coal power plant, which typically around 33 to 40% efficiency, This is almost double. This high efficiency is possible because the system does not waste the hot exhaust gas from the gas turbine. Instead, it reuses that heat to produce additional electricity through the steam turbine. As a result, more electricity is generated from the same amount of fuel, reducing overall energy waste. The second advantage is lower carbon footprint. Combined cycle plant produce about 50 to 60% less carbon dioxide compared to coal-fired power plant. This is mainly because natural gas burn cleaner than coal and produce fewer harmful emissions. In addition, CCPP produce very low amount of sulfur dioxide, nitrogen oxide and particulate matter. These pollutants are usually responsible for acid rain, smog and respiratory health problems. Therefore, CCPP is considered a much cleaner and more environmentally friendly option among fossil fuel power plants. The third advantage is operational flexibility. One major strength of CCPP is its ability to start up quite quickly and ramp up power output in a short time. Unlike coal and nuclear plants, which may take many hours or even days to start, gas turbine can begin operating within a much shorter period. This makes CCPP very suitable as a backup system for renewable energy sources such as solar and wind. Since solar and wind power depend on weather conditions and are sometimes inconsistent, CCPP can quickly adjust its output to stabilize the power grid when renewable generation drops. The fourth advantage is its small physical footprint. Compared to coal or nuclear power plant, CCPP requires less land area and less cooling water per megawatt generated. This makes it more practical to build in areas where land is limited. It also reduces environmental impact related to land use and water consumption. Because of these advantages, high efficiency, lower emission, flexibility, and smaller footprint, combined cycle power plants are considered one of the best transitional technology toward a cleaner energy future. However, like any advanced technology, it also comes with a certain disadvantages, which will be explained next.
Right. Thank you, Aki, for your explanation about advantages. Now I will present the main disadvantages of combined cycle power plant. Firstly, high initial capital cost. Compared to simple gas turbine plants, combined cycle plants require a much higher investment. This is due to inclusion of additional systems such as the heat recovery system generator, HRSG, steam turbine, condenser, and cooling system. The complexity of this component increases both construction time and overall project cost. Secondly, fuel price sensitivity. Combined cycle plants depend mainly on natural gas as their primary fuel. As a result, any fluctuation in global natural gas prices can have a significant impact on operating expenses and electricity generation costs. This dependency also exposes power sector to fuel supply risk. Third, reduced efficiency at a partial load operation. These plants are designed to operate most essentially at a full load condition. However, the demand is low and the plant operates below its rated capacity, its efficiency drop noticeable. This can affect overall system performance and economic return. Fourthly and lastly, for these disadvantages, thermal stress and increases maintenance requirements, frequent startup and shutdown cycle, especially during peak demand changes. Subject high temperature component to thermal stress. Over time, this leads to increases wear and tear, higher maintenance costs, and potential reduction in equipment lifespan. We also done for these disadvantages, and we jump into the conclusion. Alright, for the conclusion, in conclusion, combined cycle power plant represent one of the most efficient thermal power generation technology currently available. With efficiency level exceeding to 60%, they play a vital role in Malaysia's electricity system by providing reliable baseload power while significantly reducing carbon emission compared to conventional coal-fired power plant. This makes them an important transitional technology in countries shift toward cleaner energy sources. Looking toward the future, combined cycle plants are expected to evolve further through the adoption of hydrogen blended fuel and carbon capture technology. This advancement will support Malaysia's long-term energy sustainable goal and contribute to the nation's commitment to achieving net zero emission by 2050. Thank you for your attention. That's all for our group. Thank you.